Hi guys, I'm here and today we'll learn all about stars. Yes, we're gonna learn why they look so small, the different types of stars, and what happens to them later. Anyways, let's get into the video. The sun is a star, like all the other stars in the sky. But why are the other stars so small and the sun is so big? It's because of distance or perspective. Perspective is the way how you look at something. Yeah, like that's POV. Everybody wants to know my POV. Yes. As for example, the closest star, Proxima Centauri, you can't even see it. Besides our sun, the closest star, Proxima Centauri. It's because it's far away, 4.24 light years away, period. The size of the stars also matters how bright or dim they are. Proxima Centauri is a small star. 7 of them can fit across the sun. That's why we don't see it in the sky. And even though it is so small, it has 3 planets that could support life that is orbiting around it. But some stars are huge and we can't see them. Why? Let's take VY Canis Majors, for example, the second largest star we've ever discovered in the Milky Way. It's in the Canis Major constellation, and you can't see it unless you have a telescope. Because if you look into the Canis Major constellation, it isn't there. Why? It's because it's 4,000 light years away. 1 light year equals 9.25 trillion kilometers. So you may think the sun is a medium-sized star, but it's not. Let me explain. A year ago, I found a list. I lost the list, but I do remember if you scroll down all the way down to number 197, there's Sirius, a white main sequence star just like the sun. Wait, the sun is white? I'll get to that later in the video. But even though it is big, it will become a white dwarf. What is a white dwarf? I just mentioned Sirius, but did you know that there's a star orbiting it? This star is called Sirius B. It's a white dwarf star. The sun will become a white dwarf in 8 billion years, just like Sirius B. When a white dwarf runs out of fuel, it turns into a red dwarf. But what is a red dwarf? Just like the name suggests, a red dwarf is a red star that is small. At the beginning of the video, I mentioned Proxima Centauri, the closest star besides our sun. Proxima Centauri is a red dwarf. Red dwarfs live a very, very long life because they don't burn as much fuel. But I thought you said that red dwarfs are stars without fuel. Okay, they haven't exhausted all their fuel, but most of their fuel. And since they burn fuel very, very slowly now to save fuel, they will live a very, very long life. Remember what I said, that the sun will become a white dwarf and it's not big enough to become something? Then what is it? It's a black hole. A black hole is something that nothing can escape, not even light. There are many types of black holes, but the 2 main types of black holes are stellar and supermassive. Supermassive black holes are in the center of a galaxy. For example, Sagittarius A is a black hole at the center of the Milky Way. And did you know that being sucked into a stellar black hole is worse than being sucked into a supermassive black hole? Yes, if you get sucked into a stellar black hole, you'll be spaghettified before you even pass the event horizon. However, with supermassive black holes, you'll be able to go through the event horizon, falling until you reach singularity. Then you will be sucked into singularity. However, your friends or friends will just see you falling, freeze, and then just slowly disappear. This is because we can't see past the event horizon. Don't worry, the black hole will turn into a white hole, but that will take 1 Google years. But since you're inside the black hole and the black hole warps space-time, it may feel like no time at all. But when you get launched out the black hole, you'll be a random set of particles. Sometimes stars don't have enough mass to turn into a black hole, but have way too much mass to turn into a white dwarf. Then they turn into neutron stars. Neutron stars are the smallest type of stars. Neutron stars have so much mass that if two of them are merged, then they could become a black hole, creating a gamma ray burst. And they have really extreme gravity. If you were above a neutron star, then you won't be able to even lift a needle. You would just be flat as a pancake. Pulsars and quasars are the same thing, but just spinning faster and with more gravity. But what causes gravity? Mass. Mass is how much weight something is. The bigger an object is, the more mass it has. However, Uranus is bigger than Neptune, but Neptune has more mass. And Pluto is bigger than Eris, but Eris has more mass. Also, really small stuff like neutron stars, pulsars, quasars, and stellar black holes can be really massive. This is because these are dead stars. When a star dies, the core collapses on itself, but the mass stays the same, creating a neutron star, pulsar, quasar, or black hole. Also, the more mass something has, the temperature will be higher. Look at this chart. Blue stars are the hottest or most massive. White stars are hot. Yellow stars are in between. Orange stars are cool, and red stars are the coolest or least massive. And how do I know about mass? Look at this photo. This photo contains the two most massive stars in the universe, and they're both blue stars, which are the hottest. Did you notice that stars could also be planets at the same time? Yes. These stars are called brown dwarfs. These stars are around 74.8 times the mass of Jupiter. The largest brown dwarf we've ever discovered is HD 100,546b. Since a brown dwarf is both a planet and a star, this is the biggest planet ever discovered as well. Do you remember when I said earlier in the video that the sun is white, and I'll get to it later? Well, here we are. In this part of the video, I'll talk about why the sun is white. The sun doesn't absorb any of these colors. It reflects. It's making it white. But the reason why it's yellow is because of its solar flares. And before you go, here's a quick fact. Did you know that Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto can fit between the Earth and the Moon, and there would still be 2,000 kilometers left of space? Well, the sun is bigger than all these objects in a row. So let's see what will happen if we put the sun between the Earth and the Moon.